my dear students. Welcome back to the class. Welcome back to Ask IITians. How are you all? How's everything is going on? So, have you watched the last session? That last video in which we have started our chapter, that is the separation of substances from mixture. I hope that the chapter name must be separation of substances from mixture. Otherwise, students say from what we are separating the substance exactly, or it's just that they are just going to be very short, like a very short form, like which we generally use on our WhatsApp group while we chatting with our friends or something, some other person. So this is the chapter. So my dear students, fine. Now coming to the very energetic mode, we are going to study this chapter. And like in the last session, what we have discussed what is the mixture. We have seen like mixture can be of three types: solid, liquid, liquid. And I have told you that gases mixture also there, but it's not like that. You are going to study all of these things right now. Otherwise, you can be considered as a PhD holder for this chapter. Okay, so we are just going to study very basic right now. So in the last session, we have discussed about the separation of solid and solid mixture, and we have seen that we can use four techniques for that. First is hand picking, threshing, winnowing, and sieving. So we have done these four things till now. Exactly. So now, my dear students, today we are going to study something new. Okay. So do you remember what is mixture? Exactly. So the mixture is a, like you can say it as a mix, like when we are having different components, when we have different substance, when we mix them together, so we get a different type of mixture, and we used to separate that mixture by using different techniques depending upon the type of the mixture. Exactly, student. So we are going to see, like in the last session, we have done the separation of solid and solid. Now, my dear student, in this session, we are going to see that how the separation of solids from the liquids. Like one, we are having liquid form, one we are having the solid form. So when we are having the mixture of these two, so how we are going to separate them? For example, student, solid, that is the salt. For liquid, it could be the water. So when we add them, so we get some kind of mixture which we called as the salt solution. Okay, so how we are going to separate the salt and water? So we are going to use up these method. Fine. So my dear student, have you noticed one thing here, that is the separation of soluble solid and the separation of the insoluble solid. So there are two things, as you have seen also in your last chapter, in your maybe that is about the separate sorting of materials depending upon their solubility. So at that point, I have also taught you about the soluble solid and the insoluble solid, that we are having some solids which are easily dissolved, like you can say soluble in some material, that they are going to be completely dissolved. For example, salt, sugar. But we are having some type of solid also which are insoluble in nature, that they are not going to be dissolved in the water or in any other in any other liquid. See, okay, student. So what the thing is, student, that the solid, and when we have liquid. So in term of chemistry, we call the solid as the solute. We call the liquid as solvent. And when solute and solvent mixed together, so we get the solution. Okay, students. So when you're going to a higher classes, definitely you are getting the type of solution. But for now, what you can remember, that the solid is considered as the solute. The name, it is the name we have given just to it. Liquid is considered as the solvent. So you can say it's not always about solid can be solute or the liquid can be solvent. It's not always like that. You can say that the substance or the component which is going to be dissolved in any other substance, we call it as the solute, and the substance in which any other material is going to be dissolved, we call it as the solvent. For example, in water, salt is going to be dissolved, so salt is a solute, and the liquid, the water which is going to, like in which the solute, that salt is going to be dissolved, we call it as the solvent. So there are the two things, solute and solvent, and when they both mix with each other, we call it as the solution. Generally, we talk about the solution for liquid and the solid. Okay. So in that condition, solute can differ, that is the solid can be differ. How? It can be soluble in nature. That means it is completely going to be dissolved in liquid. And the third is the insoluble. That means it is not going to be dissolved in the water. For example, student, if I talk about for the soluble, that is the salt, sugar, and insoluble if I talk about sand, stones. So these are the things which are not soluble in water. Exactly, like if you try to dissolve them, still you can't dissolve it because they are very you can say very hard, very large size, so they can't going to like they are not able to dissolve in water. So we call the water as the universal solvent for, okay. So generally when we talk about the solution, so we take the liquid as the solvent, that is the water as the solvent. So you can say that H2O, that is water, it can be considered as a universal solvent. Okay, and just remember one thing, student, like the solvent can be anything, but when we talk about the liquid and solid, so the liquid is considered as the solvent because in that particular thing we are going to dissolve the solid part, and the solid is called as the solute. That means we are going to dissolve that thing into the liquid. So that is the solute and solvent, and the mixture of it we get solution. And the solute, that is the solid, is of two types. One is the soluble thing, one is the insoluble thing. So to separate out the soluble solid from liquid, we are having these two methods. One is the evaporation, second is the crystallization. And for the separation of insoluble method, we are having these: sedimentation and decantation, filtration, centrifugation. Okay, I hope you got my point. So now if I ask you to use the threshing method or the winnowing method to separate the salt and water solution, so will you be able to do that? You will say, ma'am, what are you talking about? You are just making us fool. We can't use that. We are very much smart. We know that we can't use that method. So now we are going to discover these new methods, and we'll see that how we can separate out such things. Okay. So my dear students, first of all, we are going to study about the separation of the soluble solid. That means the solids which are soluble in water or in any other liquid, we are going to first of all study about the separation of such things, okay, such components. So, okay, even I don't know that we are having this question. So what's the question is saying? Do you know why toned milk is good for your health rather than the normal milk? If I'm having a live class, so right now I would having so many answers from my student, but we'll get the answer that you can think about it and then we can get the answer. Okay, after discussing all of these things, you will definitely having this answer. Actually, I'm having the answer right now, but it's just that before telling you the techniques, I don't want you be to get confused. So first of all, we'll read all of the techniques, okay, or the processes. So the first process is the evaporation process, and we are using to separate out the soluble solid, that is the solid which is soluble in nature, from the liquid. Okay, so that is the thing. So what's the evaporation, student? For separating a mixture of a non-volatile and a volatile substance by evaporating one of them. See, student, now what's the volatile and non-volatile first of all? So the volatile substance are those substances which can easily evaporate, like you just give heat and they just get evaporate in the atmosphere. So we call it as the volatile substance. Okay. Evaporate easily. And the non-volatile are which don't. Now you will say, ma'am, evaporate, what you are talking about evaporation. So my dear student, evaporation is a technique in which what you will do, for example, you are having a mixture of salt and water. And if I ask you to separate the salt from the water, so what you can do is you can take any of the pen and you can pour that solution in that pen and you start heating it. When you start heating it, student, what will happen that the water which is having the boiling point that of 100 degrees Celsius, so by consuming that heat, the water is going to be evaporate into the nature, into the atmosphere, and that's how we just left with the salt. So that is the evaporation, student. So for the evaporation, what we required exactly, we required heat. Okay, and from that heat what we can see, if either of the substance which is volatile in nature, it is going to be evaporate in the atmosphere, and we can see that the another substance is left behind, and that's how we have separated the solution. So student, we know this thing that when we give heat to the water, so that water convert into the vapor form. Exactly, you have also seen this thing at your home, that when you boil the water, so you have seen that the vapors are forming from that. So that is a student, when you're having salt solution or the sugar solution, we know this thing that the water can evaporate easily. So when you start heating it, so what happened from the mixture, that the water is volatile, so it is not exactly, you can say that so exactly volatile, that it is going to be evaporate into the atmosphere when it is reaches to its boiling point. And that's how we are just separating these two components, that one is the soluble solid and another one is the liquid. So evaporation method can be used at that point when the mixture is having one volatile substance and one non-volatile substance. Okay, if both are the volatile in nature, so you can see that both can be easily evaporate in the nature. And if we are having both as the non-volatile, so what could be possible, that both are remain into the pen, no one is going to be evaporate and no one is going to be separate. Exactly, so we have to use the such type of mixture in which one is volatile and one is non-volatile. For example, salt and sugar is not volatile in nature, that when you start giving heat, salt is not going to be evaporate in the atmosphere, it's just that the water which is going to be evaporate. So to separate the mixture which is having the non-volatile and the volatile mixture, that one could be the solid, one could be liquid, so that's how you can evaporate it by using the heat only. Okay, so you can see here applications: separating colored component from the ink, salt from water, sugar from water. You can see that this is the salt solution. Okay, when you start heating it, so what will happen? When you start heating it, so the temperature is going to be increased at that point. Exactly, temperature is going to be increased, and when the temperature is going to be increased, when the water, we know this thing that the water is having the boiling point. Boiling point means when the water is going to be convert into the vapor form. It is 100 degrees Celsius. So at this temperature, the water is going to be convert into the vapor form. You can see that this is the vapor form it is converting, and after that, what you will see sometime, that you are just left with the salt, and all of the water has been evaporated into the atmosphere. And you can see now there is the separation of these two components. Same thing can be happen with the sugar as well. So my dear student, have you seen that the evaporation of seawater, it is a very important application, that the seawater, student, it is salty in nature. That is why we don't generally use the seawater in our household work, because it is salty in nature, and due to that salt, our clothes can be get very you can say rough, our skin can get rough. So that's why we don't use seawater in our household work. So my dear student, that salt which we are using in our houses, we generally use to get it from the seawater. What we do, that we dig a large size pit, and in that pit we pour the seawater, and the sunlight, that the sun will act as a source of the heat, and due to that sunlight, water gets evaporate from that pit, and we just get the salt from that. Okay, so the common salt which we use in our houses, that is the white salt. It's generally prepared by this method only, because the seawater is salty in nature. So we just evaporate the water, and then we just process that to salt, so that the impurities can be removed, and then we get the salt, that is the white salt, and we use that salt in our houses. So that is the evaporation, student. That means, so in evaporation, what we do, that one should be in volatile in nature. So here the water is volatile, and salt, and this salt is non-volatile, and even the sugar as well. So when you increase the temperature, water reaching to its boiling point, and water evaporates in the atmosphere, and we just left with salt or sugar. So that is the application of it. Now, how it is happening? See, the explanation could be here. See, these are the particles. See, student, these balls are representation, the particles of the, you can say particles of water, something like that. When you give the heat to it, okay, when you give the heat, so these are going to be evaporate into the atmosphere. And when it is going to be evaporate, so you can see that the water level is going to be decreased. Exactly. So what we can see here, when we start heating it, so due to the heating process, what will happen? That the temperature is going to be increased. And when the temperature is going to be increased, so what will happen, student? That the water will convert into the vapor form. And when it is going to be converted into the vapor form, so obviously the content of water, content or the level of water is going to be decreased in the beaker or something like that, and you just left with the you can say the another particle, that is solid or sugar. Even the student at your houses, when you just boil the water, only water, so you have seen that before boiling you are having the more content of water, and when you have done with the boiling you have the less content of water. It is because, student, some of the water particles have been evaporated in the atmosphere in the form of the vapor, due to which the content will decrease, that the heat is there and they are converting into the vapor form, so they are removing from here, and you can see that the content of water is going to be decreased. So that's the whole explanation behind the evaporation. That means the more heat you will provide, so what will happen, that the temperature, it is going to be same. Okay, heat, when you start heating, so temperature will increase, and that's how evaporation will also going to be increased, and that's how the water, all of the water converts into the vapor form, and we just left with the solid part. So that's how this same technique is used to prepare the salt from the seawater. Okay, so this is the evaporation, students. But it is used when one is the volatile in nature and one is the non-volatile in nature. If both are the volatile, if both are the non-volatile, you can see that it could not be possible to separate them out. Exactly. So both can be evaporate in nature, or otherwise both will remain in the beaker only. So we are not going to separate them. That's how. So that is why this method is generally used up when we are having one volatile and one non-volatile. Oh, by mistake, I just press the button. So now the next method is the crystallization. So my dear students, what happened in the crystallization? That we form the crystals. Okay, that means crystals are the solid kind of thing, and we see, student, like we can see that the evaporation is using for the volatile and non-volatile thing. In this thing, that we are just left with the you can say, we are just left with the non-volatile thing. But in the crystallization, student, what will happen, that we get the some type of crystals at the end, and that crystals can be shiny in nature, that it could be shiny in nature, and they are solid and they are having some definite shape, you can say. So that is the crystallization process, student. Now you will say, ma'am, in the crystallization what we'll do? So my dear student, as you can see that this is the copper sulfate solution in this china dish. This china dish you can see in the laboratories. Okay, so this is the copper sulfate solution. When you start heating it, this is the boiling water. This is passing out the heat to this bowl. When you start heating it, students, so what will happen? The unwanted thing or the unwanted water which is present over here, it is going to be evaporate in the nature. And after some time, what you will observe, that there is the crystal formation of the copper sulfate. Crystal formation of the copper sulfate, and that is the crystallization process, student, that when you get the pure form from impure form. So that is how we use the crystallization process. Fine. So in the evaporation, what is happening? One is the non-volatile and one is the volatile thing. And even though here also you can see that the water or the extra amount which is present over here, it is going to be evaporated by this heating process. And after some time, you are getting the some crystals of copper sulfate here. Exactly. Because it is the solution of copper sulfate only, so you are getting the crystals of the copper sulfate. So that is how, student, evaporation and crystallization, these two methods, because in that evaporation you are not having any crystals, but here what happened, you are having the solid crystals after the evaporation method. So this is the crystallization process, student, and it is also used to separate out the solid material from the liquid material. Like this is the copper sulfate solution, so what it will having the copper sulfate and some amount of water, And again, when you heat it, so the water gets evaporated and the crystal is going to be formed. For example, in the case of the salt, we are not having the exact solid particle, we are having it in the powder form. So in the crystallization we got the crystals, but in the evaporation it's just that we separate out the material which is completely soluble in that. So one is the volatile and one is the non-volatile. So these two methods can be used for the separation of the soluble compound, soluble solid from the liquid. One is the evaporation and another one is the crystallization. Okay. Now we are going to study the method in which we are going to separate out the insoluble solid from liquid. So we can take a very simple example, that is the sand and water. Because student, what happened that the sand is insoluble solid. Like when you can take one beaker of water, as you can see here, you can add sand into it. Okay, I'll show you again. When you mix it, so what happened, you just keep it for some time and you can see that this sand is going to be settled down at the bottom, this mud settle down at the bottom. Okay, so the settlement of this insoluble material at the bottom of the beaker, so you can say that this process is called as the sedimentation process. So this technique is used wherever we have to settle down the impurities. Okay, so you can see here it is a technique through which dirt and other heavier particles in a mixture settle down at the bottom of the flask or the vessel, and when water is added to it and the mixture is allowed to stand for a while. Exactly, student. For example, when you have taken the water in the beaker and when you add the sand into it and when you stir it, okay, so what will happen, you will just keep it for some time, like you don't have to be disturbed, you just keep it undisturbed. So after some time, what you will see that the sand particle is going to be settled down at the bottom. Sand particles, dirt particles, or you can say that the heavy particles are going to be settled down at the bottom. So student, this process, the settling of that dirt particle or the heavier particles, the impurities, so that process is called as the sedimentation process. Okay. Now, when the sedimentation is done, when the particles has been settled down, so you can see here now, this is a mud. This is the sedimentation process. Now, you can decant this water. Because student, what happened, like all of the water which is present over the sand, you can separate it out this form, and this called as the decantation process. So my dear student, what is the decantation? It is a technique through which immiscible liquid or a liquid and a solid substance are separated out. We'll see what is immiscible liquid means, the liquids which are not completely mixed with together. So decantation process, you have seen here that when the sand has been settled down at the bottom, so the decant water which is present over the sand, so you can decant it out by using the other beaker, so that the water is going to be separate out in the another beaker, and that process is called as the decantation process. See here, like this person is transferring this liquid into the another beaker, the sand is not has been transferred. Sand is in the first beaker only. This is the only liquid. Okay, this is the liquid only, and this is called as the decantate, and this process, the transferring of the decantate into the another beaker, is called as the decantation. Now, using of these strainers, so you can see that the use of this strainer can be done as the filtration process. Okay, so that's how student, the sedimentation, decantation and filtration follows by each other. Filtration, when we have to separate the very small particles like dirt or anything else from the solution, so we can done this filtration process, and this is generally done with the help of the filter paper. Okay, so just try to understand here. So first is the sedimentation, then it is decantation, then third it's the filtration. How? See students, initially when you having a mixture of sand and water, fine, when you are having one beaker, you add some water in it and you have add some sand in it and you just stir it. And what you have do is like you have just keep that beaker for some time undisturbed. Now you are not disturbing it. So what you will see that when the sand is settled at the bottom of that beaker, so that process is called as the sedimentation. That means sand has been sedimented at the bottom of the beaker. Now in that beaker, what you have seen, like this is a beaker. So there is the sand. Okay, this is the sand, and here over it is the water. So this water can be decantate now. This is the decantate water, so that you can transfer this water into any other beaker. But now this water is having some small dirt particles. So what you can do, you can take another beaker and you can transfer this water over here. And this process is called as the decantation process. That means the transfer of the decantate from one beaker, which is having the sand part also, which is having the sedimentation in that, you can transfer it into the another decantate, into the another beaker. That is called as the decantation process. Now the third step. Now this water which has been decantated, it is having some small particles of dirt or something like that. So now it is going to be purified by using the filtration process. In filtration process, student, what we can use is we can use the filter paper. See student, that filter paper are having some pores, and that pores are made up in such a way so that only water will get flow out of it. Okay, and the other remaining particles, that the impurities are remaining in that, so we don't have to worry about it. So that's how the filter paper has been made. For example, student, as in this thing, you can see that this person is using a funnel kind of thing over here. The strainer is here and he's passing over it. So the another particles will remain here and the liquid is going to be flow down. So student, filtration process is done to purify the water. For example, the purification process which is going on in our ROs, which we use in our houses. So what happened, there is also a kind of filter paper, and that's how through that filter paper only can water pass out, whereas all the other impurities will left over there. And that is why you have seen that the change of that particular filter paper at the regular basis is very much required. Exactly, because the dirt has been collected over it. So we have to always change it. If we don't have to change it, so what will happen, we are not getting the good quality of water. So that is why student, this is the three things in which what happened, we have the insoluble solid, that it is not soluble in water, but the dirt can be soluble. Exactly. So we follow these three process. First, sedimentation, that we first allow it to settle down. When it is going to be settled down, so at the upper layer we are just having the water because the solid particle has been settled down at the bottom, and then very carefully we transfer that liquid into another beaker, which we call as the decantation, and then that liquid which is having the small dirt particles has been purified or filtered by using the filtration process, by often using the filter paper. Oftenly we use the filter paper, but yes, you can use the strainer as well. The strainer can also be used, but it's just that depending upon the dirt particle size, because if it is very small in nature, it can be passed out through the pores of strainer. So that is why we require filter paper. And filter paper is also of different sizes. It's not like that only one type of filter paper is there. We are having different filter paper which are having different pore size, so that student, only and only liquid will can flow through it. Fine. So you can see that this is the funnel which we use, and over it we have used this filter paper. And when you are pouring water in it, so this is the solid residue, that is the dirt particle and something like that, and the water is going to be flow it out. That is the filtrate process. So that is the filtration process, student, in which small dirt particles are removed by the help of the filter paper. Okay, and how that filter paper are having pores in it, and the pore size is only about that only and only water can pass through it. Water can pass through it, and the dust particle, you can see it will remain over the filter paper, and when you have passed all of the filter, you can collect this filtrate, and this filter water is called as the filtrate. So this filtrate you can carry in, you can collect in any of the beaker or any of the container, and then you can use it. Fine. So that's the filtration process. So first sedimentation is done, then decantation, and then filtration. Okay, so that is the process. So these are the method which we follow up to separate out the insoluble solid from the soluble one. Oh, sorry, insoluble solid from the liquid one. Now this is the another method that we call as the centrifugation method. So in this centrifugation method, student, it is also used up for that technique in which the insoluble material is there and the liquid is there. So method to separate the denser particles from lighter particles in a solution. Like when we have to separate out very dense particles from the lighter particles. So we use the centrifugation method. As you can see, separating milk from the cream. When we used to separate the milk from the cream, so we use this centrifugate machine. So what will happen? It just start rotating it and the cream will get separate out from the milk. So you can see here, student, that milk is the lighter material and cream is a denser material. So when we used to separate the denser material from the lighter material, we use the centrifugation process. It's just that in the centrifugation process we need rotations. Separating butter from cream, squeezing out water from wet clothes. Exactly, student, when we have to squeeze out the water, so we have to roll that clothes, exactly, so that the water will get come out from it. So that is the centrifugation process, student. That means in the centrifugation process, student, we require some rotation kind of thing, that we have to rotate it with at a high speed so that the denser material will get separate out from the lighter material. For example, milk from cream, butter from cream. Okay, so this is the last method to separate out the insoluble thing, insoluble solid from the liquid. For example, student, like in my houses, I have seen this thing that my mother used to rotate, like with her hand, what she do, like she used to rotate the cream part so that butter will get separate out from it. So the butter is more denser than cream and the cream is more denser than milk. So that is how milk is lighter, and from that milk we are getting cream, and cream is lighter than butter. So from that cream we are getting the butter. So that is how centrifugation process is also used up. So these are the method. Now, my dear students, if this question is here, do you know why toned milk is good for your health rather than normal milk? So my dear student, what happened that the normal milk is having some fat content in it. Okay, so what happened, generally you have also seen when your mother purchased the milk from the milkman and she used to boil it. Why? Because what happened, student, when she used to boil it, so that you are having some cream over it, because all of the fat will get accumulate at one point and you can remove from that and you are just having the toned milk. That means you can say that the toned milk is having the less content of fat, less fat is there. That is why, student, toned milk is good for our health, because the fat, you can see na, that fat can increase the weight. So that is why we don't require the fatty things to be in our use. That is why, student, toned milk is good for our health, because the normal milk will having the more fat content, and when we boil that normal milk, so what happened, when we boil it up, after some time when we cool it down, so what will happen, that the fat content will accumulate over the surface of the milk and we can remove it, and after that milk will have the less fat content. So that is how, that is the toned milk, and that was the normal milk. So the normal milk having the more fat content, whereas the toned milk is having the less fat content. So that is why it is good for health. Okay, so you can see we are separating out the fat content from the milk, that is the denser substance from the milk, but you can't say that it is the centrifugation only, because, student, you are boiling it up. Okay, so how would you separate sugar from a solution of sugar and water? Exactly, you can do it by using the evaporation method. So that what will happen, that water is the volatile one and the sugar is the non-volatile one. Exactly. So when you heat it up, so water gets converted into the vapor form and the sugar will left behind. So that's how you can separate both of them. So that's how, student, the question can come like, what's the difference between the evaporation and crystallization? So you will say in the evaporation, the water gets evaporated and we get another solid thing. But in the crystallization, we get the crystal thing of that particular solid. Okay, so that is the crystallization and that is the evaporation. and like this can be asked. And now like the filtration, sedimentation, decantation, these three are very similar, so you can get the question like that, that what could be the basic difference. So I have already told you, like in the sedimentation there is the only settling down of the dirt particle at the bottom or the solid particle at the bottom. Then we are having the layer of decantate water, then you transfer that water, that is called as the decantation. And when the decantation will let the decantate water having some small particles which can be filtered out by using the filter paper, that is called as the filtration process. And then we have seen the centrifugation, which is done for the lighter particles, like the to separate the denser particle from the lighter particles, like here the milk from cream, butter from cream. So that's how, student, milk is very lighter. Oh, just a second. Hurry. I don't know why it is not getting selected, this eraser. So it's just that milk is very lighter, then it is cream which is very denser, then it is butter. So that is why, student, first of all we get cream from milk and then we get butter from milk, because they are more denser and we are getting them from the lighter particles. So we generally use the centrifugation method, and for the centrifugation process we have to rotate it at a high speed so that the denser substance will get separated out from the lighter substance. So this is the separation method from the solid and the liquid, and even though the solid, like soluble one and the insoluble one. So for the soluble one it's evaporation and the crystallization. For the insoluble one it is filtration, sedimentation, decantation and centrifugation. So my dear students, till now what we have discussed the separation of solid and solid, separation of solid and liquid, and now in the next session we'll see the separation of liquid and liquid. Okay, and I hope you get all of these points. And my dear students, after watching this session, even though if you're having any question, any doubt, any query comes in your mind, you can post your question over the public forum as well as the private forum, and definitely you are getting your answer. And in the next session we'll just covering up this whole chapter, sorry. So till then, study more, revise all of the things, and you having any doubt, post your question. Fine. And watch all of the video with a great attention. As I've told you, you are getting all of these techniques in your high standard as well. So just clear all of your doubts at this point only, so that your basics will be clear and you are completing your higher education very easily. Okay. So thank you everyone.